Hey everybody, welcome to Learn With. Today, we're diving deep into the fascinating world of steel. It's more than just a hunk of metal, it's the backbone of our modern world. Bridges, skyscrapers, even the tools we use every day. But not all steel is created equal. There's a whole universe of different types of steel, each with its own unique properties and ideal uses. So whether you're a seasoned engineer or just curious about the materials that make up our world, stick around and let's unlock the secrets of steel. Let's kick things off by answering a fundamental question. What exactly is steel? You might be surprised to learn that steel is, at its heart, mostly just iron. See, iron in its pure form is actually pretty soft and easily corroded. Not exactly ideal for building skyscrapers, right? That's where carbon comes in. By adding a small amount of carbon to iron, usually less than 2%, we completely transform its properties. It becomes harder, stronger, and more durable. We can add other elements too, like manganese, silicon, or chromium. Each one tweaks the steel's characteristics in a different way, allowing us to fine-tune it for specific applications. So how do we actually make steel? It starts with iron ore, a rock containing iron oxides. The iron is extracted in a blast furnace. Mixed with coke and limestone, impurities are removed. Hot air melts the iron, creating pig iron. It's refined to remove excess carbon. Finally, it's cast into shapes like slabs or billets. Remember how we talked about adding different elements to steel to tweak its properties? Well, that's where steel alloys come in. Adding elements like chromium, nickel, molybdenum, and vanadium creates unique steel properties. Chromium resists corrosion, nickel adds toughness, and molybdenum boosts high-temperature strength. By controlling alloying elements, we create diverse steels with unique properties. With so many different types of steel out there, it's no surprise that they find their way into a vast range of applications. Steel is the unsung hero of our modern world, quietly underpinning countless aspects of our lives. Think about the infrastructure that surrounds us. Bridges, tunnels, skyscrapers, even oil rigs. All of these rely on the strength and durability of structural steel. Then there's the transportation industry, where steel forms the backbone of cars, trucks, ships, and airplanes. And don't forget about appliances, cookware, and even the cutlery we use to enjoy our meals. Now let's talk about alloy steels, the rock stars of the steel world. These steels are specifically engineered for peak performance in demanding applications. Take high-strength low-alloy steel, or HSLA for short. It's designed to be lightweight yet incredibly strong, making it ideal for bridges and other structures where weight is a major concern. Then there's tool steel, which, as the name suggests, is used to make tools that can withstand heavy use and high temperatures. And for applications where corrosion resistance is paramount, we have stainless steel. Alloy steels are like the special forces of the steel world, deployed when ordinary steel just won't cut it. Take, for example, the aerospace industry. Jet engines, rocket components, and aircraft landing gear all rely on the exceptional strength, heat resistance, and durability of alloy steels. Then there's the energy sector. Oil and gas pipelines, often operating under extreme temperatures and pressures, depend on the resilience of alloy steels to prevent leaks and ensure safe transport. From the depths of the ocean to the vastness of space, alloy steels are pushing the boundaries of what's possible. Now let's talk about steel grades. With hundreds of different steel grades out there, it can feel like navigating a labyrinth. Steel grades are essentially standardized systems for classifying steels based on their chemical composition, mechanical properties, and intended applications. Different countries and organizations have their own grading systems, which can make things a bit confusing. Each standard uses a specific alphanumeric code to designate different steel grades, providing a shorthand way to identify and compare steels from different manufacturers. Selecting the right steel grade for a project is a critical decision. Choosing the wrong grade can lead to performance issues, premature failures, and even safety hazards. So how do you ensure you're making the right choice? First, consider the application's specific requirements. What kind of loads will the steel be subjected to? What are the environmental conditions? Will it be exposed to high temperatures, corrosive substances, or cyclic stresses? Don't hesitate to consult with material suppliers or industry experts to get their insights and recommendations. Let's shine a spotlight on carbon steel, the workhorse of the steel world. It's the most widely used type of steel, and for good reason. As the name suggests, carbon steel is primarily composed of iron and carbon. The carbon content, typically ranging from 0.05% to 2%, is the key factor influencing its properties. Low-carbon steel, with its low carbon content, is known for its ductility and weldability, making it ideal for applications like sheet metal, wire, and structural shapes. Just like its alloyed cousins, carbon steel comes in a variety of grades, each tailored for specific applications. One of the most common grading systems for carbon steel is the AISI, or American Iron and Steel Institute 10 series. The first two digits, 10, indicate that it's a plain carbon steel. The last two digits represent the approximate carbon content in hundredths of a percent. For example, AISI 1018 steel contains approximately 0.18% carbon. Another widely used grading system is the SAE, or Society of Automotive Engineers, J403 standard. Let's roll into the world of bearing steel, a specialized type of steel designed for the demanding world of bearings. Bearings are those unsung heroes that allow rotating machinery to operate smoothly and efficiently. Bearing steel needs to be exceptionally hard and wear-resistant to withstand the constant friction and rolling contact within a bearing. It also needs to have good fatigue resistance to withstand millions, even billions of stress cycles without failing. Chromium steel, often alloyed with molybdenum and vanadium, is a common choice for bearing steel due to its excellent hardness, wear resistance, and dimensional stability. Now let's bounce over to spring steel, a type of steel specifically engineered for its remarkable elasticity and resilience. As the name suggests, it's commonly used to manufacture springs, those essential components that store and release mechanical energy. Spring steel needs to possess a unique combination of strength and flexibility. High-carbon steel, often alloyed with elements like silicon, manganese, and chromium, is a popular choice for spring applications. These alloying elements enhance the steel's strength, toughness, and fatigue resistance, allowing it to endure countless cycles of compression and extension without losing its springiness. Get ready to be energized as we explore electrical steel, a specialized type of steel designed for its magnetic properties. Also known as silicon steel or transformer steel, it's an essential material in the world of electrical engineering. Electrical steel is used to manufacture the cores of transformers, motors, generators, and other electromagnetic devices. Its unique composition and microstructure allow it to efficiently channel magnetic flux, minimizing energy losses and maximizing efficiency. The secret to electrical steel's magnetic prowess lies in its silicon content. Get ready to delve into the world of cast iron, a ferrous alloy that's been around for centuries. Unlike steel, which is typically shaped by rolling or forging, cast iron is poured into molds while molten, allowing for intricate designs and complex shapes. Cast iron has a higher carbon content than steel, typically between 2% and 4%, along with varying amounts of silicon and manganese. This high carbon content makes it brittle, meaning it's not ideal for applications where impact resistance is crucial. However, cast iron's brittleness is offset by its excellent compressive strength, wear resistance, and machinability. Let's step outside and explore weathering steel, a type of steel that's designed to develop a protective rust layer when exposed to the elements. Also known as Core 10 steel, it's often used in outdoor applications where a distinctive rustic aesthetic is desired. Weathering steel contains a small amount of copper, along with other alloying elements like chromium, nickel, and phosphorus. When exposed to the atmosphere, these elements react with oxygen and moisture to form a stable reddish-brown oxide layer on the steel's surface. This oxide layer, unlike ordinary rust, is actually beneficial. So there you have it. We've journeyed through the world of steel, from its humble beginnings as iron ore to the incredible array of alloys and grades that shape our modern world. Remember, choosing the right steel is like choosing the right tool for the job. Understanding the properties of different steel grades and the influence of alloying elements is key to making informed decisions that will ensure the success of your projects. Now that you're armed with this knowledge, go forth and create. Thank you for joining us on this journey through the world of steel. Don't forget to like, share, and subscribe for more informative content.